Handling errors and exceptions. Defensive programming can help mitigate future errors in some cases. Defensive programming is an approach that is used to improve software and source code in terms of the following: by reducing the number of software bugs and problems, making the source code comprehensible. The source code should be readable and understandable so that it is approved in a code audit, making the software behave in a predictable manner despite unexpected inputs or user actions. Exercise: implementing the try except block. The simplest way to handle errors is to use the try except block. The code in the try section is executed, and if an error which is specified in the except block is thrown, the code in the except block is executed. Once the block finishes executing, the rest of the code executes as well. This prevents errors from causing your program to crash. Let's see an example. We are going to use the code example that we used to describe the file not found error in the previous section to demonstrate the try except block. Write the following script with open input.txt file r is its mode, and as my input file is file object, I iterate all the lines in my input file, print all the lines, see the output. No such file or directory input.txt. This is an error. As you can see, the error caused the execution to stop before the last line. Rewrite the same code with the file not found error handled using a try except block. Use try keyword after this colon with open input.txt file, its mode as my input file. Iterate all lines in my input file, print all the lines except file not found error. It means if this error will raise, then print file does not exist, and at the end print execution will continue. See the result. File does not found, execution will continue. By using try except block, the program will never crash. After wrapping the code in a try except block, instead of crashing, the script executes the code in the except block and continues to next line. You can handle more than one exception by creating a tuple like this. Try with open input.txt file, its mode r as my input file. Iterate all the lines in my input file, print all the lines except file not found error, value error. It means if file not found error and value error will raise, then print file does not exist, print execution will continue. See the result. File does not exist, execution will continue. Sorry. The program will never crash due to the use of try except block. A better way is to handle them individually and do something different for each error you get. Implement this as follows. Start the try block with open input.txt r as its mode as my input file. Iterate all the line in my input file, print all the lines except file not found error, then it will print file does not exist, and if except value error, then print value error occurred, and execution will continue. See the result. And this one, file does not exist, execution will continue. The program will never crash due to the use of try except block. In this case, only the except clause for the file not found error will be executed. However, if a value error also occurs, both except clauses will be executed. If you are not quite sure which exception will be thrown, you can catch the generic exception, which will catch any exception that's thrown. It is a good practice to catch the generic exception at the end of more specific except clauses and not by itself. Implement it like this. Start the try block with open context manager, input.txt file, its mode R as my input file. I iterate all the lines in my input file, print all the lines except file not found error, then print file does not exist, except value error, a value error occurred, except print something unforeseen happened. Print execution will continue to here. See the output. Execution will continue to here. File does not exist. However, doing this is a bad practice. Start try block with open input.txt, its mode R as my input file. I iterate all the line in my input file, print all the lines except exception, print something unforeseen happened. Print execution will continue to here. Something unforeseen happened. Execution will continue to here. The program will never crash due to the use of try except exception. However, both approaches are valid syntax and will work just fine. Exercise: implementing the try except else block. In this exercise, we will implement the try except block with an additional else statement. The try except else block is a minor modification of the traditional try except block so that it can handle an else block. The code in the else block is always executed if no error has occurred. Implement the try except else block as follows. Start the try block with open input.txt file. R is its mode as my input file. I iterate all the lines in my input file, print all the lines except file not found error, then file does not exist, except value error, then print a value is occurred, except general exception, print something unforeseen happened, else print no error, files exist. Execution will continue to here. Run the code. File does not exist because file not found error will raise. Execution will continue. It means program will never crash. Exercise: implementing the finally keyword. The finally keyword defines a code block that must execute before the try except block exits, irrespective of whether any exception occurred. It is usually the last block in the try except block after all the exception handling logic and will always be executed. Continuing with our file reading example, the finally keyword can be implemented like this. Start the try block with open input.txt file, its mode R as my input file. I iterate all the lines in my input file, print all the lines except file not found error, then print file does not exist, except value error, print a value error occurred, except general exception, print something unforeseen happened. Finally, print I will always show up. Run the cell to see the output. File does not exist. I will always show up. This is the output of finally block. Execution will continue to here means the program will never crash. Activity number 38, handling errors. You are completing some code but you have an unhandled error. What do you do to make sure that the error does not stop your program prematurely? In this activity, we will practice handling errors. The following code throws an error. Import random, print random dot rand integer 1 through 10. Identify and handle the error so that when it occurs, the message "oops, something went wrong" is printed to the terminal. or on the output screen or on the output window. Solution of activity number 38. Import random module, start try block, print random dot rand integer 1 up to 10. Accept attribute error, print oops, something went wrong. Run the cell. Oops, something went wrong because rand integer is no attribute because rand integer attribute will not available in random module. Custom exceptions. Built-in exceptions cover a wide range of situations. Sometimes, however, you may need to define a custom exception to fit your specific application situation. For example, a recipe not valid error exception for when a recipe is not valid in your cooking app. In this case, Python contains the ability to add custom errors by extending the base exception class. Implementing your own exception class. Exception should be named ending with the word error. Let's create the recipe not valid error class we talked about previously as a custom exception. Class recipe not valid error extend from exceptions. It means inherit from exception class. Define the constructor of the class recipe not valid error and set the attributes self.message is equal to your recipe is not valid. Start the try block, raise recipe not valid error, accept recipe not valid error as a, print e.message, run the cell. The result is this: your recipe is not valid. Thank you very much at the end of this course.